Good evening, everyone. This is P. Sai Kumar Reddy, and today I am going to give a technical seminar on adaptive cruise control. Let's get started. The contents are introduction, physical overview, components of ACC system, control system interface, physical layout of ACC system, advantages, disadvantages, conclusion, and references. The introduction. Adaptive Cruise Control, also called as ACC, is an automotive feature that allows a vehicle cruise control system to adapt the vehicle speed to the traffic environment. And the second point is a radar system attached to the front of the vehicles is used to detect whether slower moving vehicles are in the ACC vehicle's path. This process is introduced in 1970s in USA, and this system is now available in luxury cars like Mercedes S-Class, Jaguar XJ, Volvo trucks. And this is the physical overview of an adaptive cruise control. In this, VH is a host vehicle speed and VT is a target vehicle speed. In this, VH contains a radar sensor which transmits data to the control with the help of sensing. The control is directly connected to HMI, which is also called as human machine interface. Human machine interface are features and components of car hardware and software applications that allows drivers and passengers to engage with the vehicle as well as outside world. This HMI and control is directly connected to brake command so that it automatically applies the brakes. Components of an ACC system. ACC module. The primary function of the ACC module is to process the radar information and determine if a forward vehicle is present. Next is engine control module. The primary function of the engine control module is to receive information from the ACC module and instrument cluster and control the vehicle speed based on the information. And then is brake control module. The primary function of the brake control module is to determine vehicle speed via each wheel and to declare the vehicle by applying the brakes when requested by the ACC module. Instrument cluster. The primary function of instrument cluster is to process the cruise switches and send their information to the ACC and engine control modules, and then CAN. This is also called as controller area network. Is an automotive standard network that utilizes a two-wire bus to transmit and receive data. Each node on the network has capability to transmit 0 to 8 bytes of data. And then brake switches. There are two brake switches, brake switch 1 and brake switch 2. These are also called as front brakes and back brakes. Cruise switches. The cruise switches are mounted on the steering wheel and have several buttons which allow the driver to command operation of the ACC system. The switches include on button, which is used to place system in the ACC standby state, and then off button. It is used to cancel ACC operation and place system in the ACC off state, and then set plus button. Activate ACC and establish set speed or accelerate. Set minus button. It is used to declare the speed, and then re- rest button. It is used to resume the speed, and then coast button. It is used to declare or cancel the ACC system mounted on the steering. Let's come to control system interface. Currently, three means of object detections are technically feasible and applicable in the vehicle environment. They are radar, lidar, vision sensors. First, let's talk about radar sensor. It is also called as radio detection and ranging. Radar is an electromagnetic system for the detection and location of reflecting objects like aircrafts, ships, spacecrafts, or vehicles. It is operated by radiating energy into space and detecting the echo signal reflected from an object. It works reliably under low visibility conditions such as cloudy weather, snow, rain, and fog. It is present in the front of the car or vehicle. After radar, let's come to LiDAR. It is also called as light detection and ranging. A typical LiDAR sensor emits pulsed light waves into the surrounding environment. These pulses bounce off surrounding objects and return to the sensor. The sensor uses the time to look for each pulse to return to the sensor to calculate the distance traveled. LiDAR is an optical remote sensing technology that measures properties of the scattering light to find range and other information of the distant target. The prevalent method to determine distance to an object or surface is to use the laser pulses. Like the similar radar technology which uses radio waves instead of light, the range to an object is determined by measuring the time delay between the transmission of pulse and detection of the reflected signal. LiDAR, the first ACC system introduced by Toyota, used this method by measuring the beat frequency difference between a frequency. In this given above figure, we can observe the light system which is used by LiDAR. After LiDAR, let's come to fusion sensor. The new sensor system introduced by Fujitsu 10 Limited and Honda through their PATH program includes millimeter wave radar linked to a 640 into 480 pixel stereo camera with a 40-degree viewing angle. These two parts work together to track the car from the non-moving objects. These and then while radar target is the camera rear bumper, the stereo camera is constantly captures all the objects in the field of the view. In this diagram, we can see that the distance measurement, velocity measurement, darkness availability, weather measurement, object classification, lateral resolution. These all are handled by fusion sensors, and we can also see the other uh, another diagram which we can see the differences between the vision, radar and lidar. In vision we can have only cameras and software. In radar it has radio detecting and ranging. In lidar it has light detection and ranging. Now let's talk about the physical layout of an ACC system. In the first picture, it is the whole physical layout of an ACC system. In this, with the help of radar, lidar and fusion sensors, the vehicle holds the speed or applies brakes when needed. And now let's talk about the second picture, which is example of an ACC system. It is called as Motorola ACC. The Motorola ACC consists a DSP module having MGT5200 which provides a multiplier accumulator. The sensor data as a radar information the from camera and IR sensor are processed in it to generate the input data from the controller module like HC12 and MPC565. MPC565, it is a throttle controller or an engine speed controller. It consists of the following features. The MPC 565 can be programmable to generate the control signals according to the sensor data. The PyCore MPC 565 developers are available to program and develop the desired controller. The throttle valve is actuated and the air intake is controlled so the requirement of fuel for the right proportion with the air also increases, so more fuel is injected and inner speed is changed. And then let's talk about HC12. 68 HC12 has 28-bit accumulators A and B, two 16-bit registers X and Y, a 16-bit programmable counter, a 16-bit stack pointer, and a 8-bit condition code register. The 68HC12 is a 16-bit microcontroller family from Freescale Semiconductor, originally introduced in mid-1990s. The architecture is the HC12 is a braking controller which receives data from the wheel speed sensors and from the DSP module. It generates the braking control system. And then let's talk about CAN. It is also called as Control Area Network. CAN bus is the network established between microcontrollers. It is a two-wire half-duplex high-speed network for high-speed high applications with short messages. It can theoretically link up to 20-32 devices on a network, but today the practical limit is 110 devices. It offers high-speed communication, rare up to 1 mbits per second, and allows real-time control. Each module in the ACC connected to the CAN is called node. All are acting as a transifers. The CAN bus carries data to and from all nodes and provides quicker control transfer to each module. The actuator used for throttle control is a solenoid actuator. The signal through the coil can push or pull the plugger. Now let's talk about advantages. The driver is relieved from the task of careful acceleration, declaration, and braking in the congested traffic. A high responsive traffic system that adjusts itself to avoid accidents can be developed. Since the braking and acceleration are done in a systematic way, the fuel efficiency of the vehicle is increased. It has the better driving comfort. And now let's talk about disadvantages. A cheap version is not yet released, and a high market penetration is required if a society of intelligent vehicles is to be formed. Encourages the driver to become careless. It can lead to service accidents if any system is getting malfunctioning. The ACC system not yet evolved enabled vehicles to cooperate with the other vehicles and hence do not respond directly to the traffic signals. And final, the conclusion is the accident caused by the automobiles are injuring lakhs of people every year. The safety measures starting from airbags and seat belts have now reached to ACC, SACC and CACC systems. The researchers of Intelligent Vehicles Initiative in USA and Ertico program of Europe are working on technologies that may ultimately lead to vehicles that are wrapped cocoon of sensors with a 360-degree view of the surroundings. It will probably take decades, but car accidents may eventually become as rare as plane accidents are now. Even though the road laws will have to be changed up to the extent since the non-human part of the vehicle controlling will become predominant. And these are the references I have referred for the technical seminar. If you want, you can pause it and have a look on it. And that's the end of the presentation. Thank you for watching the video. If you like the video, please like, share and subscribe to my channel.